Which of the following functions is entire? We have a polynomial, p of z. We have e to the z. We have the sine and cosine of z. We have 1 over z. And we have the principal branch of the log of z. So an entire function, let's recall the definition. A function is called entire if it is analytic at every single point in the complex plane. And to be analytic at a point means that the function is differentiable in a disk around the point. So an entire function has to be analytic at every point, which means that for short, it just has to be differentiable at every point. So our p of z function has a derivative. That derivative is 3z squared plus 4iz minus 5. And that is for all z in the complex plane. So the polynomial function is differentiable at every point. So the polynomial p of z is entire. And similarly, e to the z sine z and cosine z are also entire. The derivative of e to the z is e to the z. The derivative of sine z is cosine z. And the derivative of cosine z is negative sine z. And these equations hold for all z in the complex plane. And that means that e to the z, sine z, and cosine z are entire functions. They are entire. Now, the last two are not entire. The derivative of 1 over z is negative 1 over z squared, so it does have a derivative in general, but not at 0. The function is not even defined at 0, and its derivative also does not exist. The formula for the derivative also shows that it's not differentiable at 0. So 1 over z is analytic in what's called the punctured plane. The punctured plane means the plane, the complex plane, without the number 0. So it is not an entire function. Because there is a point in the complex plane at which the function is not differentiable. And also log z has a derivative. The principal branch of the logarithm, the derivative is 1 over z, and that derivative does not exist at z equals 0. And so this function is also not entire. But more can be said. The logarithm is not differentiable on not only at 0, but on the negative real axis where it is not continuous. And this is called the slit plane. So the log z is differentiable on the slit plane, and so it is not differentiable at any of the points on this red line here, and so it is not an entire function.